Okay, in this example we're going to use the quotient rule to differentiate a function divided by another function. And the first step here is to let that equal to u over v. So if u is equal to 2 sine 5x du by dx, sine becomes cosine and the 5 comes outside, must be equal to 2 times 5 is 10 cosine 5x. And if v is equal to 5x to the power 4 dv by dx, our 4 comes down, multiplies by the 5, and we get 20. 20 times x to the power 4 minus 1, 20x cubed. So that's the basic differentiation done. We now need to apply the quotient rule. And this rule is used where we have a function divided by another function, as is the case here. So dy by dx is equal to v times du by dx minus u times dv by dx, all divided by v squared. So we have everything we need now up above here. We have u du by dx, v dv by dx. What we simply need to do now is plug these into our quotient rule. And of course our v also goes down here, v squared. So just inserting our values. V is 5x to the power 4, du by dx is 10 cosine 5x, minus u, which is 2 sine 5x, times dv by dx, which is 20x cubed. That's all divided by v squared, and v is 5x to the power 4. So we can multiply out the top line a little. So 5x to the power 4 times 10 becomes 50x to the power 4 cosine 5x. 20x to the power 3 times minus 2 becomes minus 40 x to the power 3 times sine 5x. On the bottom line here we have 5x to the power 4 all squared. So that becomes 25. When we square the indice, we multiply it. So 4 times 2 is 8. Now can we simplify this a little bit further? So what can we take out that's common in the top line? We can certainly take out x cubed. And we can also take out 10. So we have 10x cubed upon 5x cosine 5x minus 4 sine 5x all divided by 25x to the power 8. So that's fairly close to a final solution. We could divide the top and the bottom by 5 here, and we could also divide it by x cubed. So we could simplify a little bit further. 2 5s and 10, 1x cubed. So 2 over, there's 5 5s and 25, so 5. We're cancelling out the x cubed, but we still have x to the power 5 on the bottom line. That's all upon 5x cosine 5x minus 4 sine 5x. And that is our final solution. So let's review the steps. Find the differential coefficient. That's the same as saying find the rate of change of y with respect to x, or find the derivative, or differentiate the following. It's easy to spot that this is a function divided by another function, so we need to use the quotient rule. We let the top line equal u and the bottom equal v. We differentiate u with respect to x, we differentiate v with respect to x, and then we apply our quotient rule. And applying the rule simply involves plugging in our values bit by bit and then simplifying, multiplying out the top line, squaring the bottom, and then factorising to get our final answer.